All right, in this session, I want us to check the concept of arithmetic sum or the arithmetic series. Okay, so this is given by, when we talk of sum, we denote it by Sn. Okay, we denote sum by Sn. All right, so the formula for this arithmetic sum, okay, it's given by Sn is equals to n over 2 into 2a plus into n minus 1 multiplied by our difference. Okay, so this is the formula that we use to calculate the sum. Or we can also use this formula here. Sn is equals to n over 2 into a plus l. Okay, so you can see that this Sn is standing for sum. Okay, n is the position, then a is the first term, n is the position, and then d is our difference. So this is the sum, position, first term. So l in this case is for the last term. Okay, so but 99 or 98% time we're going to be using this first one. Okay, because it's not in most cases whereby you are given a series whereby it has the last term. Okay, but if so, it means you are like, you can use the second formula to calculate the sum of that particular pattern. Okay, so remember we're dealing with an arithmetic sum. So what exactly is the sum? When we talk of sum, we know that we're talking of 1 plus 2 plus something. Okay, when we see a positive or an addition sign between terms, that means we're dealing with a sum. So for an example, suppose you are given a pattern like this. We are given 9 plus 11 plus 13 plus 15 plus, then the pattern goes there. Okay, so this is an arithmetic series. Why is it an arithmetic? Remember, in arithmetic we have what we call the common difference or the constant difference. Okay, so if a question comes and they say to you, calculate the sum of the first 20 terms. They want you to calculate the sum of the first 20 terms. Okay, so in this case, we're going to use this formula here. So this formula needs you to know the number of terms that you are calculating the sum for, and in this case we are given 20, and then our a value is the first term. Okay, and then our d is our common difference. So how do we find the common difference? We know that d is equals to t2 minus t1. Okay, so the difference here, we're going to say 11 minus 9, and then we get 2. So this is our common difference. So remember, we're calculating the sum of the first 20 terms. Okay, so the sum of the first 20 terms, we're looking for S20. And remember, Sn is equals to 2 over, or n over 2, 2a plus into n minus 1 d. So this is the general rule for calculating the sum. So we are looking for the sum for the first 20 terms. Okay, so it means when we see n, we're going to put 20. Then this is 20 over 2 into the first term, 2 into the first term. The first term is 9 there. The first term is 9. Then plus into n is 20 minus 1. Then our difference is 2. Okay, so you can simplify this, and then we're going to have 10 here, and then inside the bracket we're going to have 18 plus into 19 multiplied by 2. Okay, so when you punch your calculator, you will have an answer of 560. So this is the sum of the first 20 terms. Okay, so this is what we will be dealing with when we talk of sums. Let's consider this example here. You are given the arithmetic series, okay, 18 plus 24 plus 30 plus 300. So it means this 300 is the last term of this series. Okay, so the first question says determine the number of terms in this series. Just like what we were doing when we were dealing with sequences, if we know the value of the last term, it means we can find its position. All right, so in this case we're still talking about an arithmetic. Okay, so to find the number of terms in this sequence, we use the old way that we know. Okay, so this is Tn is equals to a plus into n minus 1 multiplied by difference. Okay, we're answering number 1. Okay, so we know that our Tn value is equals to positive 300. Okay, then we want the position of this value. Okay, so it means we're having 300 is equals to the first term, it's 18 plus into n minus 1. Then what is our difference? Difference is d is equals to t2 minus t1. Okay, so we can say this is 24 minus 18, and then we get 6. Even if you can say 30 minus 24, you will get 6. So our difference here is it's 6. Okay, then let's simplify this expression. We take this 18 to the other side, then it will be negative 300 minus 18 is 282, which is equals to n minus 1 multiplied by 6. Then we divide both sides by 6. Then this 6 divide this 6, and then we are having 47 is equals to n minus 1, and then we take this 1 to the other side, it becomes positive. Then we are having 48 is equals to n. So it means there are 48 terms in this sequence. All right, so this is the first one. So they want you to calculate the sum of this series. Okay, when we hear the word sum, we know that this is an arithmetic. Then this is what we think of, right? So they want us to calculate the sum of this sequence. How many terms are there in the sequence? We know that we have 48 terms. So it means we are calculating the sum of 48 terms. Okay, so it means your n value is 48. Okay, and then 2, the first term here, it's 18 plus our n value is 48 minus 1. Then our difference here, it's positive 6. Okay, so the sum for 48 terms is equals to, we can choose to simplify, and then we have 24. Then in the brackets we are having, when we multiply the 2, we are having 36, and then plus when we multiply the 2, they were having 282. And then when we multiply everything out, we are going to have 7,632. So this is the sum of these 48 terms. I hope everything is still clear and we are still together. Okay, so number 3 says calculate the sum of all the whole numbers up to and including 300 that are not divisible by 6. Okay, They want you to calculate the sum of all the whole numbers. Okay, so from the number system, we know that the whole numbers, they start from 1. Okay, they say all the whole numbers up to 300 or including 300. So it means when they speak of all whole numbers, it's 1. Okay, they want the sum. Okay, it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus up until 300. Okay, they want us to calculate what? The sum of all the whole numbers up to 300. Okay, that are not divisible by 6. Okay, we want the sum of all the numbers from 1 up to 300 that are not divisible by 6. That are not divisible by 6. 1 is not divisible by 6. 2 is not divisible by 6. Even 3. So any number which is not divided by 6, or whereby any number which 6 divides itself and leaves a remainder, we want to find the sum of all those numbers. Okay, but the numbers that are divisible by 6, we must remove them from our series. Okay, so in this case, we must find the sum of all the numbers from 1 up to 300. Okay, we must find the sum of all numbers, okay, from 1 to 300. Okay, so notice that the difference here is we add 1 always. We add 1. So our difference is 1. Our first term is it's 1. Okay, so to calculate the sum of 300 terms, it means you're going to have, remember, Sn is equals to n over 2a plus into n minus 1 d. So it means when we see n, we put 300 because we want the sum of all the numbers. Okay, then we'll remove the ones that are divisible by 6 later. All right, so we divide this by 2, and then 2, the value of a is 1 plus 300 minus 1, then the value of d is 1. Okay, so this becomes 300. Then inside here we're going to have 301. Then this is divided by 2, and then now the sum of those numbers, it's 45,150. It's 45,150. So this is the sum of all numbers from 1 up to 300. Remember, the sum or this set of numbers, inside these numbers there are those numbers that are divisible by 6. Okay, so when we go back to our series here, we can see that 18 is divisible by 6, 24 is divisible by 6, even 30 is divisible by 6 up to 300. Okay, so it means that we must subtract. Remember, we calculated the sum of 48 terms, and all these 48 terms are divisible by 6. Okay, so it means that to calculate the sum of numbers that are not divisible by 6, okay, we should take the sum to be 45,150, which is the sum of all numbers, of all whole numbers from 1 to 300. Okay, and then we subtract this sum of 48 terms which were divisible by 6. Okay, and then we subtract 7, 6, 3, 2. Okay, so remember, we are subtracting all the terms that are divisible by 6, but here we start from 18, okay, to 300. So from 1 up to 18, we have 6 which is divisible by 6. We also have 12 which is divisible by 6. And then from 12 we are having 18. So we took from 18 to 300. So it means we must also subtract 6 and 12. Okay? We must subtract 6 and 12. So in this case, it means we can add 6 plus 12 to this one, because this is the sum of all the numbers divisible by 6. We are removing them from the sum of all terms. So it means now our final answer is 37,500 there. Okay, so this is the sum of all numbers that are not divisible by 6. I hope it makes sense. This was a tricky question, but this is how we can approach it. Okay, so we can look at another example so that we can understand this sum and how it can be thrown to us at different angles. Okay, so this is an interesting question and many learners are complaining about such questions. Okay, so in today's lesson, let's try to tackle this concept out. Okay, so this says the third term of an arithmetic sequence is 14 and the 10th term is 84. You just hear English when you read there, when we're in the examination hall. And you say, we subtract 5, we subtract this. I'm writing out of 140. No, don't do that anymore. Okay, so this thing is saying T3 of an arithmetic sequence is equals to 14. Okay, and then T10 is equals to 84. Okay, but remember we're dealing with what? An arithmetic sequence. And then they want you to calculate the common difference and the first term. So how do we interpret this information? We are in arithmetic sequence. When we're given an arithmetic sequence, we know that our general formula is Tn is equals to a plus into n minus 1 multiplied by difference. So when we want to find term number 3, we know that a plus, where we see n, we put 3 minus 1 multiplied by d. We know that the value for term number 3 is 14. Okay, this is what the question told us, which is equals to a. Then when we do maths here, we get this is 2d. Okay, so when they say the third term of an arithmetic sequence is 14, they mean this expression. You must derive this expression. Simple as ABC. And then here they say the 10th term is 84. Similarly, we do the same. Tn is equals to a plus into n minus 1 multiplied by our difference. Okay, so term number 10, if we are looking for term number 10, it means where we see n, we're going to substitute 10. Okay, we know the value of the 10th term, which is 84, which is equals to a plus 9d. Okay, so you are having two equations, an equation 2. Then we can use simultaneous to solve for d, which is our common difference. And if obviously we find d, we can find a. Okay, so you can choose to eliminate, or you can choose to make any variable the subject of the formula. Okay, so for the sake of this video, I'm going to make a the subject of the formula. Okay, so I'm going to have 14 minus 2d is equals to a. Okay, even if I can do this side, it means 84 minus 9d is equals to a. Or you can choose to make this a the subject of the formula and substitute it here. Okay, it's still fine, we will get the same answer. So since this is equals to this one, they are both equals to a, you can see. So we can say this is equation 3, then this is equation 4. I can say make equation 3 be equals to equation 4, because they are both equals to a. So it means 14 minus 2d is equals to 84 minus 9d. Okay, so now I can take this d to the other side, then I'm going to have 7d. Then when I take this 14 to the other side, I'm going to have 84 minus 14, and then I'm left with 70. So when dividing both sides by 7, our d value becomes 10. So our d value is 10, and the question was looking for our common difference, and the first term already we know the common difference, that is it's 10. Okay, so to find the value of a, you can choose any equation and substitute the d value. We should get the same answer. Okay, so I'll take this one. So it means 14 minus 2d is equals to a. Then it means 14 minus 2, the value of d is 10, which is equals to a. Then 14 minus 20 is equals to a, and then the a value is equals to minus 6. So this is what the question was looking for, the common difference and the first term. So our common difference is 10, and then our first term is negative 6. And then just like that, you are done. Okay, we have answered number 1. So now they want you to calculate the sum of the first 50 terms. So this is an arithmetic. So they want you to calculate the sum. Okay, Sn is equals to n over 2a plus into n minus 1 multiplied by the difference. So they want you to calculate the sum of the first 50 terms. Okay, so it means n is 50. We divide that by 2. What is the value of a? The value of a is minus 6. Then plus into, then the value of n is 50 minus 1. Then our d value is 10. Okay, our d value is 10. We multiply this by 10. You can simplify, or you can punch your calculator straight. Then we're having 25. Then inside we're going to have 12, negative 12 plus 490. Then when you punch everything to your calculator, the sum gives you 11,950. So this is how you can solve this question. Then we are done with this question, and I hope it was straightforward and it was not complicated. Okay, so we can check on this one here. So it says the sum of the fourth and the ninth term of an arithmetic sequence is 28, and the eighth term is 17. They want you to determine the term number 10. So remember, they're saying the sum. Okay, so you start to think of Sn, but in this case they said the sum of the fourth and the ninth term. So it means what the statement is saying, it's saying T4, which is the first term, plus T9 of an arithmetic sequence is equals to 28. Okay, and then they also said and T8, the 8th term is equals to 17. They want you to determine the what? Term number 10. All right. So we are still working with an arithmetic sequence, okay, as per the question. So it means when we want term number 4 in arithmetic sequence, it means we know that we are going to have Tn is equals to a plus into n minus 1 d. Okay, this is for term number 4. A plus, where we see n, we put 4 minus 1 difference. So for term number 4, it's a plus 3d. Okay, so this is a plus 3d. So it means term number 4, it's a plus 3d. Okay, plus for term number 9 is equals to a plus 9 minus 1d, and then this is a plus 8d. So this is a plus 8d is equals to 28. Okay, so when we add the like terms here, we're going to have a plus a, 2a, and then the 3d plus 8d, it will give you 11d, which is equals to 28. Okay, then this is our equation 1. So term number 8, so it means term number 8 will be a plus into 8 minus 1 multiplied by the difference. Okay, so you will have term number 8 as a plus 7d, which is equals to 17. This is your equation 2. I hope it makes sense. Okay, so we can make a the subject of the formula and then substitute it here. So from equation 2, which equation 2 says a plus 7d is equals to 17, we can say a is equals to 17 minus 7d. Then this is your equation 3. Then you can substitute equation 3 into equation 1. Okay, so it means where we see a, we are going to substitute 17 minus 7d. So it means we're going to have 2, then a, we substitute a as 17 minus 7d, and then plus 11d is equals to 28. All right, so then we need to multiply out. Okay, then we are having 2 multiplied by this 17, and then we get 34, and then minus 14d plus 11d is equals to 28. Okay, so when we add the 2, we get negative 3d, and then I take this 34 to the other side, and then plus 28, then it gives you negative 6, and then I can divide both sides by negative 3. Then we get that our d value is equals to positive 2. Okay, we get positive 2. So if you find your d value, you can similarly find your a value. So we can substitute d here on this equation 3 to obtain our a value. So it means a is equals to 17 minus 7d, and then this is 17 minus 7 into 2. Okay, so our a value in this case is positive 3. This is positive 3. Okay, so we haven't answered the question yet. Okay, the question was saying determine term number 10. Okay, so how do we determine term number 10 in an arithmetic sequence? We know that Tn is equals to a plus into n minus 1 multiplied by the difference. So term number 10 will be equals to, the first term is a, which is 3, okay, plus we're looking for the 10th term minus 1, and then our difference is 2. Okay, so it means we're going to have 3 plus 9 multiplied by 2. Okay, so when you multiply this out, it means you're going to have 3 plus 18, okay, then which gives you 21. So this is the value of the 10th term. So this is a hell long process, but if you can write these simultaneous equations well, then everything will flow. Okay, so I think we can check on the last example for this arithmetic so that we can move to another concept. Okay, so consider an arithmetic sequence which has the second term equal to 8 and the fifth term equal to 10. Then they want the common difference of the sequence. Okay, so the second term is equals to 8 of an what? An arithmetic sequence. Okay, so second term, we know that is T2. They say T2 is equals to 8, and then they also say the fifth term, which is T5, which is equals to 10. Okay, an arithmetic sequence. So Tn is equals to a plus into n minus 1 multiplied by d. So to find T2, it means where we see n, we substitute 2. Okay, so we know the value of term number 2, which is 8. Okay, so this is a plus d. Okay, this is our first equation. So here we're having term number 5. We can similarly say n minus 1d. And then to find term number 5, we know that where we see n, we substitute 5. Okay, so we know the value of T5, which is 10. Then it means we are having a plus into 4 or plus 4d, not into. So this is our second equation. Okay, so you can make the subject of the formula, any variable the subject of the formula, and deal with this, or we can eliminate. We can use elimination method, whereby we're having 8 is equals to a plus d, and then this side we're having 10, which is equals to a plus 4d. And then we can subtract this. Okay, and then when we subtract this, we're going to have negative 2, because this is 8 minus 10, we had negative 2. Then this one and this one will cancel out, and then d minus this one, we're going to have negative 3d. Then we can solve for d just like that. Then we divide both sides by negative 3. Then our d value is equals to 2 over 3. Okay, so this is our d value. The common difference of this sequence is what? It's 2 over 3. Okay, so the question says, the second question says, determine the sum of the first 50 terms of the sequence. Okay, then we know Sn is equals to n over 2a plus into n minus 1 multiplied by difference. We're given that we should calculate the sum of the first 50 terms. Okay, n is 50, then a, do we know the value of a? We don't know the value of a. So to find the value of a, it means we can just substitute the value of d here, and then we will find the value of a. So it means that to find the value of a, okay, we're going to take this one, or you can also take this one, but I feel the simplest one is this one. So it means 8 is equals to a plus d. Okay, so we're having 8 is equals to a plus the value of d, it's 2 over 3. And then now it means a, okay, let me not complicate my maths learners. Then we subtract 2 over 3 is equals to a. then now our a value is equals to, then we get our calculator, and then we subtract this, and then we get that this is 22 over 3. So now we know our a value. We can calculate the sum of the first 50 terms. So as 50 is equals to, then we're going to have 50 over 2 here, then 2, the value of a is 22 over 3, okay, plus into n it's 50, then minus 1, our difference, which is d, then we know that the value of d it's 2 over 3. It's 2 over 3. Okay, so you can punch straight to your calculator, and then we should get the same answer to be 3,550 divided by 3. So this is the sum of the first 50 terms of this arithmetic sequence given here. Okay, so get more questions like this. If they confuse you, deal with them. If you don't understand them very well, you can put your inquiries there by the comment section, or I will put my email on the description so that we can communicate. So from me to you guys, we'll see you on the next one. Bye bye.